So here is question 7. This is a hypothesis test, but it is unfortunately not one that you can use your the inference app on your calculator for. You need to use, basically you need to do the probability calculations yourself. So we have a mean rate of people. If the mean rate exceeds 1.5 per minute, Loreto will employ extra staff. It's Poisson distribution. Loreto performs a hypothesis test to determine whether she should employ extra staff, and she finds 320 patients arriving during a randomly selected 3-hour clinic. Write down null and alternative hypotheses for Loreto's test. So we are saying that, if we've got 1.5 per minute, we want to figure out how many we should be having in 3 hours. So that's 1 hour times 3. So we would be expecting 270, and if it exceeds 270, then we're going to have more patients. So let x equal number patients arriving in 3 hours, and we think that it can be approximated by a Poisson distribution with m as 270. I guess we should say m. M is our kind of standard parameter for the Poisson distribution. So our null hypothesis is that m is equal to 270. Null hypothesis always has to be whatever it is you're looking at equal to something. We can't have ranges. So the alternative, if it's more than that, Loreto employs extra staff. So we're checking, is it more than 270? So that is part 1. Part 2, we need to basically do the test and figure out an answer to whether Loreto is hiring more staff or not. And we're doing this at the 5% significance level. So what we want to do is we say, she's found out that there's 320 patients that arrived when she checked, when she gathered her information. So what we want to figure out is what is the probability of getting that result or something more extreme. So what's the probability that there are 320 patients arriving or something more extreme? Something more extreme in this case is more than 320. So that's what we've got to find. And we see, is that really unlikely? And really unlikely here means less than 5%. Or is it likely enough that it's just a chance? It's definitely more than 270, but is it at the point where we're going to say, no, I think there's something wrong. I think you need more staff. So let's have a look. We are doing a Poisson calculation. It is cumulative because we're saying 320 and more. Our parameter is 270, and we're looking at 320 or more. So I'm putting in a big number. There's no upper limit to Poisson. Okay, we get a very small value, 0.00166. Okay, much less than 5%. So yes, it's less than 5%. Therefore, reject HO. Sufficient evidence to reject HO. What does it mean? It means that, so maybe we should say, this is a significant result. Reject HO. And we're going to say Loreto. Is that how you spell Loreto? No, it's Loreto. Loreto should employ more staff. Okay, that is part A, done. Loreto is also concerned about the average waiting time for patients to see a nurse. The health centre aims for at least 95% of patients to see a nurse in under 20 minutes. Loretto assumes that the waiting times for patients are independent of each other and decides to perform a hypothesis test to determine whether they are meeting its targets. So this is not Poisson now. It doesn't say anything about it being normal either. What we're saying is each patient should have a 95% chance of seeing a nurse in under 20 minutes. So we need to write down a null hypothesis for this and then do the test and figure out if the health centre is meeting its targets. Okay, so B1 HO. Probability of waiting less than 20 mins is 0.95. Remember, it's got to be equal to something here. Otherwise, we don't have any fixed probability, anything to do our probability calculation with. Okay, and H1 is, I guess, that, hang on, let's have a little look. Aims for at least 95%. So, worse than at least 95% would be less than 95%. Probability of waiting less than 20 minutes is less than 0.95. That would be an example of something bad happening in this context. Okay, Loretto surveys 150 patients, finds that 11 of them waited more than 20 minutes. Okay, so if we're going to test this, what we want to do is we want to figure out what is the probability of getting that result or something more extreme. This situation is binomial. Each person has a chance of waiting less than 20 minutes or not waiting less than 20 minutes. So we've got a success failure. We are assuming the null hypothesis is true. So we've got a fixed probability. And we were told in the question that all of the times are independent of each other. So let's define a variable. I think I used x before. Let's use y now. Let y equal the number of people waiting. Well, we could do less than 20 minutes, like the question, like our null hypothesis, or we can do more than 20 minutes, like the information we've been given. It doesn't really matter which one you do. I think, because I'm talking about less than 20 minutes in my hypotheses, I'm going to do the same. We're waiting less than 20 mins. Okay, I think this is approximated by a binomial distribution. There were 150 people. And according to my null hypothesis, the probability should be 0.95. Okay, so what is the probability of getting my result or something more extreme? So my result is 11 of them waited more than 20 minutes, which means 139 of them waited less than 20 minutes. So I want to get probability of y is less than or equal to 139. Notice that the direction of my inequality matches. It's the same with the Poisson one we did before. It matches your alternative hypothesis. Okay, so binomial, we're going up to and including 139. So cumulative binomial, there were 150 people, it's 0.95, and I'm going up to 139. Oops. So that goes from 0 to 139, doesn't it? 0.132. Okay, I think our significance level was 10%. Oh yeah, there it is, 10% significance level. So this is greater than 10%. Oops, let's write it as a decimal so that they match. Greater than 0.1, not significant. Insufficient evidence to reject HO. Okay, let's just check the question, what we asked for. Clearly state the conclusion in context. Okay, so what does this mean? It means... Okay, we're talking about whether the health centre is meeting its target. So if there's no reason to reject HO, it means it's doing what it says. So there's no reason to suggest that they are not meeting their target. Insufficient evidence to suggest they are not meeting their target. Okay, so that is a Poisson hypothesis test followed by a binomial hypothesis test. Kind of quite similar in their in the process, aren't they? Setting up the hypotheses, using the toolbox to get our p-value, and then making a comparison in context.